Hey, good morning, everybody. It's 10 o'clock in Colorado, and welcome to this week's coffee break. Our topic is stairwell pressurization systems with our Manifold Group, in particular, their Pressurization Controls Division, LF Systems. Today, we have Scott Blackman joining us to go over their product line. Welcome, Scott.
Thank you, Andy. As Andy said, my name is Scott Blackman. I'm with RM Manifold Group. RM Manifold Group is an exhaust controls manufacturer out of Fort Worth, Texas. We go to market under several different brands. US Draftco handles boilers, water heaters, pool heaters, and the such. KWUSA is a partnership with Kunstner Weber out of Munich, Germany. They specialize in fireplace controls and pizza ovens. And then, as Andy said, we're talking about LF Systems today, and LF Systems specializes in dryers, high-rise exhaust, and obviously smoke control and stairwell pressurization. So why do we talk about stairwell pressurization? Well, if you remember back in 1980, the MGM Grand Fire occurred. It was actually a relatively small fire. It was contained on the first two floors and was put out in about 90 minutes. But in the aftermath, 85 people died, and over 60 of those people died in the stairwells. And the main reason for this was there wasn't any fire sprinkler, and there was no stairwell escape plan in place at the time. And more than half of the doors were locked. So people couldn't, once they got into the stairwell, they couldn't get back out. So after this and several other tragedies, fire containment moved from historically being how to protect the building to how to protect life and the building. And the biggest way to do that is to create and maintain a reasonable environment in the stairwell. Here are some definitions that we're going to see in this presentation. They come from the ASHRAE Handbook, NFPA 92 and 101, and UL 864. The one you're going to see most in this one is the Firefighter Smoke Control Station, or FSCS. Let's look at methods for stairwell containment. So there's passive smoke control systems, which have no mechanical control. They pretty much rely on barriers and gravity. And then there's active systems, which have either supply fans or exhaust fans, dampers, and controls.
Hey, Scott, so I see a lot of examples of active smoke control systems in our environment. What would be a good example of some passive smoke control systems in our work environment?
Good question. So passive smoke control would be something like a heat smoke vent on the roof of an auditorium, or a gravity ventilator of type on a small stairwell, say a 2 to 3 story stairwell, something of that nature.
Okay.
Here are some system types for stairwell pressurization. There's a single point injection, which is good for buildings up to about 100 feet, and then multi-point injection systems. On single point injection systems, there's several different ways. You can have a propeller fan on the roof, you can have a centrifugal fan on the roof, or a centrifugal fan on ground level. And
diagrams show a couple different fan types that I just like to go over and what Pinbury offers in this scenario. Going from left to right, what's shown as propeller fan, we'd actually be using a centrifugal upblast smoke ventilator. And the other fans would be different types of utility set fans, which we carry our commercial side, which is the Dynamo series or D series. And on the industrial side, we have the VCR, which is the freestanding utility set fan. We can also provide an assortment of axial fans from mixed flow, vane axial, tube axials, and all these fans would be UL heat and smoke rated for both belt drive and direct drive.
Absolutely. The other type of system is a multi-point injection system, and that's where you have a centrifugal fan either on the roof or ground level, and it's at different points. And if I understand it right, this is kind of fairly common up in the Denver area, isn't it?
Yes, absolutely, Scott. On a lot of the past projects I've worked on, the multiple point injection technique is very common. This could have a pressurization fan and or exhaust fan, modulating relief dampers, control system devices comprising of manual pole alarms, smoke detectors, safety switches, transducers, and of course, life safety dampers.
Very good. Another type of multi-point injection that you might see is something that's used in very tall buildings where you have a series of smaller centrifugal fans in zones, if you were. So instead of relying on one very large fan to pressurize an entire stairwell, you may have fans, smaller fans placed along the rise of the stairwell itself. Everything you've seen up to now, you're probably very familiar with, have already seen, but let's take a look at how we control these. So everything within the dotted line here needs to be UL 864 listed. That includes your FSCS, your FACP, your controllers, your operating interface, and also your point logic controller. So any controller that controls the VFD, fans, dampers, things of that nature is considered a point logic controller and should be UL listed.
Hey Scott, what does LF System provide that sets itself apart from the competition or just the standard smoke control system shown in that diagram?
So I'm glad you asked. So our manifold uses our expertise in PID loops from boilers and water heaters and the laundry exhaust systems. We added a fast-acting relief damper to reduce the pressure spikes over the system. We created a dedicated UL 864 point logic controller. We use multiple transducers to monitor the pressure up and down the stairwell. And you can use Pinberry fans or any other fan you choose, as long as it's UL listed.
We'll be using Pinberry only, baby.
There you go. So let's take a look at one of these systems. So we call it our Active Compensated Stairwell Pressurization System, or ACSP for short. It consists of an L864 controller, up to 3 pressure transducers, a modulated relief damper if needed, a VFD, and wall probes.
So Scott, in this scenario, we would typically provide a Yaskawa Z1000 without bypass, which when we have the L864 controller integrated in the smoke management system, it seems like we can simplify the VFD on our end and go down to just our standard V1000 drive. All the functions of the Z1000, such are the PI control, which is a proportional integrated control for pressure, emergency override, also known as a fireman's override, and the fan speed status can be managed from that L864 controller. To me, this looks like a great engineered package solution to a complex smoke control system. And the great thing is it's all UL listed.
Correct. It's all UL listed and it's plug and play pretty much. Let's take a closer look at the L864 controller. It's a point logic controller. It uses, like I said, up to 3 transducers to monitor the pressure in the shaft. Now, one good thing about this is you can monitor the pressure based off high pressure, low pressure, or it can take an average of the 3. This can be determined either before install, but it can also be field programmed and changed after it's been installed. It has monitors for the inlet of the fan for the smoke detector and fire smoke damper. It has a dedicated I/O for the FSCS and a dedicated input for the manual pull.
Hey Scott, can you go into what's viewable on that L864 digital interface?
Sure. So it's the L860 or L864 is fire engine red. It has a 7-inch color touchscreen monitor. You are able to monitor and view all the pressures within the stairwell. You're also able to see what the relief damper is doing. You're able to also see what the fan's doing. You can go in there and also manually change it if need be, and raise and lower this fan speed manually if you so choose.
Pretty slick.
Let's take a look at the hierarchy of the 864. So as you can see here, the FSCS or the manual pull will activate the 864. The 864 will then control the VFD. It will also control and monitor the fire smoke damper and fire smoke detector on the inlet of the fan to prevent smoke from circulating back into the stairwell. And it can also feed all this information to the BMS either via BACnet or LAN.
So I understand this system works great for buildings 10 stories and below, but what do we do when we start getting into larger buildings?
So great question. When you get into larger buildings, we recommend our advanced ACSP. As you see here, it's got an L864 controller, your pressure transducers, relief damper, and VFDs, but it adds in an 850 controller and an injection point damper. And the 850 controller is an independent point logic controller. It controls up to 2 pressure transducers and an injection point damper. It also has a dedicated I/O for the 864 panel. The injection point damper uses a 2-second fast-acting actuator. This is the fastest actuator in the industry. We actually worked with the manufacturer to develop this for our needs. And then we use an opposed blade damper for precise air control. So let's take a look at how this lays out. So in a scenario using an advanced ACSP, you would have your L864 controller and your pressure transducers monitoring the pressure inside the duct itself. And then it would be controlling the VFD and ramping the fan up and down to keep a set pressure inside the duct. Then in each of your injection points, you would have an 850 controller with 2 pressure transducers and a injection point damper. Basically, you would zone this out. So we recommend every 2 floors having a zone. NFPA allows up to 3. Anything beyond that requires a smoke study. So basically, you would have a injection point damper at each section, and these independent L850 controllers would modulate the damper according to the needs of that zone.
So where do life safety dampers come into play regarding the multiple point injection system? To me, it looks like we wouldn't need as many life safety dampers, and at each injection point, we'd actually provide your IPR dampers. Does this system reduce the amount of life safety dampers needed?
It absolutely does. So basically, you would have a fire smoke damper on the inlet of the fan, like I said, to keep smoke from circulating back into the shaft or the stairwell. But then after that, at each injection point, you wouldn't have a fire smoke damper. You would use our IPR damper instead.
Okay. And as far as functionality and operation, can the L864 controller manage multiple stairwells? And how does this look in a fire alarm control panel room?
So the L864 is dedicated per stairwell. So you would have one 864 per stairwell. And basically they would all be lined up beside the FSCS. And the fireman could go through there and see each stairwell and what it was doing in real time.
Okay.
Let's take a look at the hierarchy of the 864 and the 850s. So again, as you see, the FSCS or manual pull activates the 864. The 864 sends a start-stop signal to the 850, and the 850 controls the IPR damper independently. Now, the 864 then again controls your VFD, fire smoke damper, and fire smoke detector, and feeds information to the building management system if needed. Now, on a side note, we do offer a prefabricated shaft system. This is a UL-listed 2-hour fire-rated shaft. It is a flange-to-flange connection. If you're familiar with boiler flue, it goes together the same way. Flange-to-flange connection with V-bands. It's a plug-and-play system. It has taps already built in from the factory at designated points. And basically, you can stack this any way you want it.
Does this qualify for zero clearance to combustibles?
So UL doesn't have a listing for zero clearance to combustibles for a shaft per se. They use fire ratings of 1 and 2 hours, and this is rated for 2 hours. It is, however, built to the 2-hour or to the zero clearance standard of factory built grease duct.
Is there a special enclosure we have to put around this fire rated shaft, or can it run bare, or?
It can run bare. You can run it inside the stairwell. You can run it exterior of the stairwell. You can leave it exposed. It is actually a 2-hour rated shaft and duct all in one. So you don't have to do anything but put this together. And if you're running it exterior, like I said, leave it exposed or put a facade around it.
Okay, pretty cool. Well, thank you everybody for joining. We really appreciate it. This concludes this week's coffee break. Next week, we'll be jumping into laboratory exhaust fans with our fan manufacturer Pinberry, and this will be presented by Josh Likes and Lee Sexton of Pinberry. I just want to thank you, Scott. I appreciate you helping me putting together this presentation and taking the time out of your schedule to do this. Greatly.
Oh, thank you for having me.
If anybody needs to contact me as far as questions, my information's up there. And thank you very much. We'll see you next week.